Okay, so today we're going to talk about tangents. Okay, so we're going to talk about tangent properties that happen with circles. And this is pretty big. There's some key properties that are going to happen today that are important for you to know. So just a quick reminder, a tangent is a line that intersects a circle in exactly one spot, right? I kind of just it intersects your circle in exactly one spot. All right, so that's what a tangent is. So our first property here says a tangent to a circle is perpendicular to the point, to the radius drawn to the point of tangency. So a tangent to a circle is perpendicular to the radius drawn to the point of tangency. Okay, so what that means here, this radius AE is intersecting this tangent AN, and because it's a radius intersecting at that point of tangency, it's creating a right angle. Same thing is happening here at EG. Okay, we got right angles there. I'm going to make some more connections with that shape here in a second. We're going to do one more part, and then I'm going to make some connections for you. Okay, so the next property says tangent segments to a circle from a point outside the circle. So if you have two tangent segments coming from the same point, the tangent segments are congruent. The tangent segments are going to be congruent. All right, so here's where I want to make this connection. So if they're coming from that same point outside, these two tangent segments are congruent, right? Keep in mind, AE and GE are radii, right? So they have to be congruent. What shape did I just make? A kite. So tangents, when you connect them, then the radii to the points of tangencies actually make a kite. So all those kite properties are going to hold true. Okay, now we just learned that angles A and G here for that kite are going to be right angles because we have radii going to the points of tangency, right? Okay, so now think about, we know there's how many degrees in every quadrilateral? 360. 360 if I add all four angles together, right? Automatically, because this kite is made with tangent lines and radii, this has to be 90, this has to be 90. We've dedicated 180 degrees here and here, right? That means then angle E and angle N are going to add up to be 180 degrees as well. Okay, that's kind of a shortcut that you're going to see that works here in a minute. Okay, so because we have to force A and G to be right angles, because they're radii going to the points of tangency, then that means E and N are going to be supplementary as well. Okay? Just kind of keep that in the back of your head for a second. Now, we have a formula. We have a formula, so angle N is equal to, so if I want to find the measure of angle N, the formula that's commonly used is 1/2 of the major arc minus the minor arc. So these two tangent lines intersect my circle, and they divide it into two parts. We have a major arc, which is the biggest one, and then we have the minor arc, which is the smaller one. The only reason it matters to distinguish between major and minor is we don't want to end up with a negative measurement. So the bigger number minus the smaller number. So the formula is 1/2 of the major arc minus the minor arc. But we can use this formula. Okay, this formula will always work, but there's sometimes a faster way. So for instance, let's say I know that this minor arc is, I'm going to make it easy, 100 degrees. Let's say we know that that minor arc is 100 degrees. Could I find the major arc? Yeah, because how many degrees are there all the way around? 360, and if I take away 100, I'd be left with 260, right? So we can follow this formula. We can do 1/2 of my major arc, which is 260 minus 100. Okay, but think about this. If this arc is 100, this is a central angle, so it must also be 100, right? So we have that arc is 100, so the central angle has to be 100. Well, now think about our height. That's 90, that's 90. So then this has got to be supplementary. So then n ends up being 80 degrees. If we use our formula, we would have 1/2 of my major arc, we said was 260. So this is 260 minus 100, my minor arc. That gives me 160, so half of 160 gives me 80. I end up in the same place. Okay, and the math isn't difficult, right? That's not the hard part here. But where this, using the idea of height really helps out, is if you start getting algebraic expressions. Because what if I knew, what if I said like this was 2x plus 7? This would have to be 360 minus the quantity of 2x plus 7. Okay, so if you can think about it in terms of the height, this becomes much easier, much quicker, and you have less chance of error. Okay, and you're going to see that in a few minutes here. Two things I just want to show you some vocab here, just in case we don't do this a whole lot. But secant is another term you may come across. So secant is a line that intersects a circle in two places. So tangent intersects one time, the secant intersects twice. The other thing I wanted to bring up is something called tangent circles. So circles can actually be tangent to each other. And I only bring this up because it's come up every once in a while. People ask me what are tangent circles. I don't know if they've seen it on ACT or whatever, so I just throw it in here. So tangent or circles can be externally tangent, meaning they're outside of each other and they're just intersecting in that one spot. Or they can be internally tangent. So one is kind of nested in the other and they intersect in one spot. Honestly, we do nothing with it. I just wanted to throw it out there so you just visualize it. Okay? All right, on the back side, I have 5 problems for you to look at. I want to do the first one with you. If you get the first one, then the others tend to be a little bit easier. So this is a circle that is inscribed in a triangle, right? But I need you to look at it in a different way. These are actually tangent segments to a circle. So I know these two parts are going to be congruent, these two parts are going to be congruent, and these two parts are going to be congruent. Those are all tangent segments to a circle. So instead of saying a circle inside a triangle, it is, but those parts of those triangles are really tangent segments. Okay, so now we can match apart. So like 1 safe mark and 1 safe mark, that has to be 7.7. If this is 9, then I know this part has to be 9. If this whole thing is 15.4 and this is 9, this has to be 6.4, which means this is 6.4. Does that make sense? So a lot of this with circles is breaking it down into different shapes. So you can now finish that. I'm going to give you a couple minutes here to do those 5 problems on the back. And then we're going to talk about it. Maybe one more time. All right, so on this first one here, we had finished adding up all the sides, and I got, I don't remember anymore, 46.2. What do you got on that one? Okay, next one here. Again, we have all those tangent segments, right? So we know those tangent segments have to be congruent. All right, so we know if this side is 8, then this 3 tick marks has to be 8. This whole side is 16, so this is going to be 8 and 8. Again, 16, so 8 and 8. Again, 16, so 8 and 8. So when you add them all up, you get 64. Okay. Next one, we have tangent segments again. My tangent segments are going to be congruent. This 28.9 is the distractor. You don't need it at all. So if the tangent segments are congruent, that means that 9x minus 1 has to equal 7x plus 7. So if I subtract 7x from both sides, I get 2x. Add 1, I have 8. Divide by 2, I get 4. So x equals 4 in this case. Is that okay? Okay, next two, I'm gonna do both ways, using the kite and using the formula. Okay, so my formula says if this is 115, I need to take 360 minus 115, so you're gonna do what, 245? So it's 245. So my formula says I need to take 1/2 of 245 minus 115. Okay, so I need 1/2 of 130, which gives me 65 degrees. Okay, so if I want to think about this in terms of a kite, then I'm going to draw in my radii to those points of tangency. So that arc is 115, which means my central angle now is also 115. So then I know, remember, this has to be right angle, so these two are going to be supplementary. So I can just take 180 minus 115, and I still get my 65. Is that okay? All right. Last one. So we got 255 over there. So if I want my minor arc, 360 minus 205 is 105. Okay, so if I do my formula, I have 1/2 of 255 minus 105. That's 1/2 of 0, 150, which is 75. Okay, if I think about my kite, I'm going to draw in those radii, even if it's a bad drawing. I still get that 105 there, right? But that 105 is also my central angle. So then these two are going to be supplementary, so this has to be 75. So again, you get the same answer either way. When it becomes tricky is when you start getting expressions, and then the kite is way easier for you to think about it that way. Okay? Questions on any of that? All right, so I have your homework for you. You can work on that. You should have plenty of time to finish. Then, if you did not get the circle stuff done from yesterday, finish that up as well. Okay, so I know some people have some questions. So I can help if you need help.